This video is for the candidates who are going to do further mechanics, fields, and particles. That is Unit 4 Physics of IAL and Excel. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. Also, you can be able to join our Patreon page so that you can be able to access the PDFs that I usually provide in our YouTube channel here. So let us dive in so that we can be able to get started and see what are the main areas you need to focus on. Physics Unit 4 further mechanics and fields and particles. So you may be asked question to do with particles, and here you need to realize that paper Unit 4 is involve multiple choice. The first 10 questions are actual multiple choice, and then from there, from question 11 onwards, you are going to have the structured questions. So if you are new to ProfLearn YouTube channel, that anytime we are going to upload more tutorials, you'll be notified. So you need to understand the structure of an atom. And in this case, you can see here, in question number 1, we are told that the nucleus of an isotope of osmium, OS, and 190 neutrons to have the travels along a straight road. Drag force is 150 newtons that acts for 15 seconds. So you can see now, in order to work out change in momentum, we are going to have force, that's the resultant force times the time. So that is going to be impulse. So if you are working out change in momentum, you need to realize that change in momentum is equals to the impulse. So if you work it out, you'll get our answer 2250 kg meters per second in that case. And question 3 was talking about the linear accelerator, the LINAC, get progressively longer along the length. So something that we need to understand, why does it really continue all become longer and longer as it continues? Because this LINAC keep on accelerating the particles. So if as the particles move from one tube to the next tube, the speed increase. So that is to ensure that the LINAC must spend the same time within a given tube. So synchronize. Since these are quite coming off often, so the lengths spend more time within the tube. The next question that we need also to have a clear understanding on is about magnetic fields. And in this case, we are told the following is a symbol. Which of the following is the possible unit of magnetic flux? So at this point, what you supposed to remember is the formula of obtaining the magnetic flux. So what is the formula for flux? Magnetic flux is going to be the magnetic flux density times the area. Yeah, so which means that this is going to be Tesla meter square, because the unit for the one of the following is not a valid conclusion. So you need to understand Rutherford particle experiment was trying streams of alpha particles were passed. They were directed to a thin foil. So it was realized that most of the particles passed and deviated. So meaning that much of the space of an atom is empty. Some were deflected. So since they are positive, so meaning that there is a region where there is a positive charge, which is the center. So one of the conclusion that was not confirmed was the conclusion about protons. The nucleus contains protons and neutrons. This was done by Chadwick. Yeah, it was just later discovered by Chadwick. So that was not correct. Which of the following conclude from the tracks? So we are having also tracks here. We have a particle detector shows a particle detector shows tracks produced by two particles X and Y. So something that we have to put into consideration when we are looking at that is that because the particles are charged, as they are moving through the particle detector, they are going to ionize the gas there, and in that process visible tracks are going to be formed. Okay, and since these particles are going to, since the tracks are moving different directions, we can be able to ascertain that X and Y are having opposite charges. They are having different charges. But also, when you look at the radius of curvature, the radius of the track, you realize that this one has got a smaller track. So in that way, we can also manage to mention something to do with the amount of, or the strength of the charge available. Now, which of the following concludes the tracks? The magnetic field acting to the page, we cannot be able to conclude that based on the track. X is the positively charged, but we cannot be able to conclude the type of charge here unless we know whether they were into the page or out of the page. Then we can be able to apply Fleming's left-hand rule. So in this case, the only conclusion that we can make is that X and Y have opposite charges. Now, since they are moving in opposite directions, so basically that is the only conclusion that we can be able to make in this particular part. And then we have question number 7, whereby we are also told that the diagram shows path of two charged particles X and Y moving at the same speed in a uniform magnetic field. So you can see this as a larger radius, and this one has a smaller radius. So you can see that is equals to momentum of magnetic flux density times the charge. And since the particles are moving at the same speed, it means they are going to have the same amount of momentum in that case. So, but you realize that the radius of X is actually larger than the radius of Y. So, from the equation R is equals to P over BQ, you realize that since the magnetic flux density is the same and the momentum is the same, the radius is inversely proportional to charge at this particular value that we are having here. So what does that mean? That means that for the radius to be small, this charge must be larger or must be greater. So we can be able to say the mass of Y, the mass of Y is less and the charge of Y is greater, so that we can be able to have a scenario whereby we shall have a small radius. So in that case, that if the mass is less, it means now we're going to have less size of momentum, because the speed, the object were moving at the same speed. So the only way that we can be able to reduce the momentum at the top there is having a smaller mass. And when you have a small mass, you have less momentum. And once you increase the charge, then it means that we are going to have a smaller radius as the charge keep on increasing. So basically, the most important thing, make sure you remember how to use this formula, because that one also is a concept that has to be tested. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime we're going to do more tutorials, and more of these particular tutorials will be coming in this kind of revision, you will be in a position to answer those questions. Moving on to question number 8, and I think I need to ensure that this particular next question, I think now the screen's back, we can be able to proceed to the next question. Question number 8, we are told that a toy aeroplane is traveling in a circular path. The toy aeroplane completes 12 revolutions per second. So you need to understand that if you are told 12 revolutions in 6 seconds, you can be able to determine how many revolutions per second. And in this case, we are going to have 2 revolutions per second. What does that mean? If you have number of revolutions per second, that will mean that the frequency is 12/6. And the formula for angular velocity is given by omega 2 pi f. So since this is the frequency 12/6, then our answer now becomes this value that we have at that point. Moving to question number 9, and this is going to be the second last question on the multiple choice. Of course, we are going to have another part that we shall be talking about structured questions. And in question number 9, we are told that a capacitor discharges through a resistor, and the time constant of the circuit is 5 seconds. And what is the time taken in seconds for the charge of the plate of the capacitor to have? So in order to work out this, you need to remember that charge that is remaining is equals to the initial charge times E is to negative T over RC. Yeah, so in that way, but this part that we have here, is basically representing the time constant. And in our case here, the time constant is 5. So you are going to substitute RC with the time constant. And in that case, we are going also to divide the charge that is remaining, divide by the original charge. But we are told how long does it take for the charge to have. So meaning Q over Q naught, which is Q original, is going to be a half, because how long does it take to have? Then at that point, once we've gotten that, we are going to go ahead and introduce natural logs, whereby introducing natural logs here, we are going to have ln over half minus ln of E is to that. So I just introduced ln here, and also I introduced ln here. So you realize that ln of a half is the same as ln of 1 minus ln of basically 2. And ln of 1 is always 0. So we shall have negative ln of 2 is equals to ln of E. You need to remember from pure math that ln of E is going to cancel out. So we are going to get a 1 there, and we finally have negative T over 5. So basically negative, and this one is going to end, and then we shall remain with T is equals to 5 ln of 2. So that is why we have this part here. And that now becomes the expression that they wanted us to show at that given point. Lastly, we have a car that travels over a humpback bridge. And this is going to imply that we shall have the weight acting down and the reaction acting up. But remember now, since it's moving in a curved region, we shall have a kind of circular motion taking place there, and that is going to imply that centripetal force, which is mv squared over r, is going to be equals to mg minus r is equals to mv squared. So at that given point, it means that if you can be able to understand that there is a relationship between this car moving on a ramp, then which means that since moving at a humpback bridge, there is circular motions. You see there is a force that is going to be directed towards the center, and the resultant force is going to be equal to circular motion to the centripetal force. And the resultant force is going to be W minus the resultant force, which is going to be equal to mv squared over r. So in that case, the weight was mg. So if we make r the subject, because in this question you are asked expression from the bridge, and the expression from the bridge is basically the normal reaction force that we are having here. So we can be able to say weight, which is mg minus r, is equal to the centripetal force, and the answer for that case becomes C. Yeah, so that marks the end of the multiple choice of this particular paper. So meaning that the next part that we have is answering a structured question. How do we answer structured question in this case? So we have question number 11. Question number 11 is talking about the child in a roundabout, and these children are just having fun. They are having good time there, as we are having some good time to review this particular paper. And in that case, we are told that the roundabout is a flat platform with bars, and the children make the platform rotate by turning and by pushing these bars. It takes 12 seconds for the roundabout to make 2 complete oscillations. So which means that 12 revolutions is equals to 2 complete revolution is equal to 2 seconds. So if you want to find the frequency, it will be 2 over 12. Yeah, and or you can be able to look at it from the perspective of period. For 1 rotation, 2 rotation is equal to 12 seconds. 1 rotation is going to be equivalent to what? That is going to be, if 2 rotation is equal to 12 seconds, 1 rotation is going to be equal to what? So you are going to find 1 rotation is equals to 6 seconds, and that is now what we call the time period. So angular velocity is given by 2 pi over t, or angular velocity is given by 2 pi f. So in that case, if you work it out, you're going to get the angular velocity being equivalent to 1.89 rad per second. Now, once you have gotten angular velocity, now because we are being asked the speed, the linear speed, we are going now to use the relation here. Linear speed is equals to angular velocity times the radius. So in that case, it will be 1.05 times 1.8, and the final answer now translates to that particular part. So that is what you are expected to do in this particular question. And I think I need to move this so that you can be able to see all the steps that I've tried to explain at this given point, so that you can be able to see what you do. And next question is the question to do with electron that has that particular kinetic energy. So something that you need to remember is that in order to calculate the Boyle wavelength, the Boyle wavelength is given by Planck's constant over momentum. But momentum squared over 2m is equals to the kinetic energy. So meaning from the kinetic energy, we can be able to get momentum. So these are the kind of formulas like this one, you have to know it. Because if you have the mass of an object and you have the kinetic energy, you can be able to find the momentum of that particular object. So using that, we can be able to find momentum, and then we can now use the Boyle wavelength in order to work out the Boyle wavelength. We're going to use the Planck's constant and over that so that we can be able to get de Broglie wavelength. And you need what is de Broglie wavelength? This is a wavelength of particles which are actually moving. Wavelength of particles, especially electrons. Electrons are moving, so they can behave as waves. At the same time, they can behave as particles. So this kind of equation, I'm very sure that is an area that is very prime, an area that examiners really love to test. They like testing this particular question. And we have question number 13. And this is a force on a current carrying conductor that is placed within the magnetic field. And then we are supposed to, we are told that when the switch is closed, the reading of the balance is 2.8 grams. So meaning that when current is flowing, the reading is going to increase. So which means that there will be a force that will be acting on the wire due to the magnetic field, but due to normal, Newton's third law of motion, and then for every action force, there is a reaction force. So if there is a force that is exerted on the wire, then the wire also will exert an opposite and equal force. And that is why we are going to have a reading at this given point. So we are going to pick from here in our next tutorial. And if you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. So if you like to watch the full remaining section of this paper, check the link in the description here. I've added the link of that particular video so that you can be able to access that particular part 2 of this. See you guys. See you. Have a great time.